A little history. The E2 reaction was proposed in the 1920s by a British chemist named Christopher Kelt-Ingold. And unlike the E1 reaction, E2 reactions remove two substituents with the addition of a strong base, resulting in an alkene. E2 reactions are typically seen with secondary and tertiary alkyl halides, but a hindered base is necessary if you're working with a primary halide. The mechanism by which it occurs is a single concerted step, reaction with one transition state. The rate at which the mechanism occurs is second-order kinetics, because it depends on both the base and the alkyl halide. A good leaving group is required because it is involved in the rate-determining step, and the leaving group must be coplanar in order to form a pi bond, because the carbons go from an sp3 to an sp2 hybridization state. Looking at a bimolecular elimination reaction, commonly called an E2 reaction. This reaction is between 2-chlorobutane and sodium methoxide in methanol, and sodium methoxide will break apart into a positive Na ion and a methoxy ion, negative methoxy ion, and by the Lewis definition, methoxy ion is a strong base because it wants to give away its electrons to a positive source. We're also looking at chlorine on the secondary carbon, and chlorine is a weak leaving group because it's very small, but it's still a very electronegative element, and so it allows it brings electrons to itself, and that charge then causes it to leave. Now we see how the strong base comes in and attacks a beta hydrogen, transferring electrons. This forces the weak leaving group to leave, and then the hydrogen protons transfer, forming a double bond. A tertiary substrate will favor an E2 reaction because beta hydrogens can easily be pulled off despite steric hindrance. Review time. Which base would work best in an E2 reaction? A, bromide ion, B, water, C, sodium hydroxide, or D, glucose. The answer is sodium hydroxide, because sodium hydroxide is the most basic, and E2 reactions require a strong base to give away electrons to make the leaving group leave, and to take away the hydrogen so that the alkyl chain will form a double bond. Question 2. Which substrate would work best with an E2 reaction? A, primary, B, secondary, or C, tertiary? The answer is tertiary, because steric hindrance prevents a substitution reaction, but allows an elimination reaction because beta hydrogens are easily removed by the base, whereas in a substitution reaction, the nucleophile must attack carbons. Hydrogens are always more accessible than carbons. Question 3. What are the stereochemistry requirements for an E2 reaction? A, antiplanar, B, coplanar, or C, gauche? The answer is B, coplanar. The two leaving groups have to be together on the same plane in order to have the carbons form a pi bond. Their electrons go from an sp3 to an sp2 hybridization. In conclusion, E2 reactions are bimolecular reactions in which a strong base removes a hydrogen and a good leaving group leaves at the same time. The alkyl chain then forms a pi bond to become an alkene. The mechanisms favor large and bulky molecules so that an elimination will happen instead of a substitution.